Okay, here's a histograms question, but it covers pretty much the whole topic of displaying data. So we've got temperatures on days from the large data set, and it tells us that when a histogram is drawn for the 8 to 10 group, it's represented by a bar with width of 1 and a height of 8. Right, so let's draw up. So 10 to 12. The height is 8 centimeters. The width is 1 centimeter. Okay, but we can see that actually our class width is 2. And we know that frequency is equal to the frequency density times the class width. And here we know that our frequency was 8 and our class width was 2. So therefore frequency density is equal to 4. And frequency density is normally on the vertical axis. So what we're going to have to do is we multiply our frequency density by a factor of 2. Right, so let's look at question A. Question A says find the height and width of bar representing the 11 to 12 group. So our 11 to 12 group has an area of, frequency or area of 7 and a class width of 1. So that means that if the width is 1 and the area is equal to 7, then our frequency density, because remember frequency equals frequency density times class width, so 7 is equal to the frequency density times 1, so the frequency density equals 7, but we need to use our factor of 2, and therefore we get a height of 14 centimeters. So for A, our bar will be 1 centimeter by 14 centimeters. Okay, now we're going to estimate the mean and standard deviation of temperatures in Liming in 2015. Okay, so let's use our table just like we did at GCSE. I'm going to extend this over here because we're going to need some extra bits of information. Okay, so I'm going to need to include in this my midpoint, my fx, and then later on I'm going to need fx squared as well. I'll explain why in a second. Okay, right, so what I'm going to do, I'm going to include my midpoint here. So midpoint, remember the quickest way to do this, 4 plus 8 is 12, half that, midpoint is 6. 8 plus 10, 18, half of that is 9. So my midpoints are these. Right. So now, just like we did GCSE, if I'm doing an average, I'm going to do frequency times midpoint, and we call that f of x. So 4 times 6, that's 24, 72, 63, 80.5, 67.5, 15.5. Okay, so now for me to work out the mean, that is equal to the sum of fx divided by the sum of f. Okay, so if I add up this column here, that will give me 322.5, and I divide it by the sum of the frequency, which is that column. That will give me 31, and that means that my mean is 10.4. Okay, so I've got my mean. And remember, this is an estimate because we're using the midpoint. Now I need the standard deviation. Okay, so the formula booklet will give me the standard deviation. Okay, and what I need the sum x squared divided by n, and I'm going to take away from that my mean that I just found squared. Now, remember, in this case, the sum of x squared and the sum of and our n, I'm actually going to use the sum of fx squared, and I'm going to divide that by the sum of fx. Okay, but then I'm going to take away the mean squared just as we did before. So that's why I'm going to need my extra column. So now I'm going to call this f of x squared. So literally I'm going to do the frequency 4 times my midpoint squared. So 4 times 36 gives me 144, 648, 661.5, 925, 75, 911, 25, 240, 25. Right. So my sum of fx squared is 322. Oh no, sorry, that's not it. Oops. When I add that up, I get my standard deviation, which is 2.4. Again, remember, the calculator will do all this. You just need to know how to use the stats functions on the calculator. Again, Casio have lots and lots of videos on YouTube to explain how to do that. Right, now we need to use linear interpolation. So for C, use linear interpolation to estimate for the lower quartile of the temperatures. Right, so I want the lower quartile. So lower quartile, remember, is Q1. So I take the total of the frequency and I divide that by 4. So 31 over 4, that's 7.75. Okay, now I'm going to use my number line. So up to, I know that basically the 7.75th person is going to be in this group, because the first 4 in this group, the 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th people are in this group. So, so on the top, I'm going to put cumulative frequency. So I've got from 4 people up to 12 people. I'm looking for the 7.75th person. And I look at my values. My group, my lower limit for my class is 8 and my upper is 10. So I want to find out what that 7.75th day, what the temperature was. So what I do, I take my starting point, which is 8, because I know that it's more than 8. And now I'm trying to work out how far along it is within my interval. So between 4 and 7.75, sorry, that's 3.75. And that's out of the whole interval, which is 8. Right, so that's the fraction that I've travelled along my interval, 3.75 out of 8. And then what I'm going to do, I'm going to multiply that by the class width, which is 2. So that means I'm getting a fraction of the class width, and I'm adding it to my start point. So now I've got 3.75 over 8 times 2 plus my 8. That gives me 8.9375, which is about 8.94, which is the correct answer. So that is our linear interpolation. Okay, now D says estimate the number of days this time in May in which the temperature is higher than the mean plus 1 standard deviation. Right, so first thing we need to do is work out what is the mean plus a standard deviation. Well, the mean was 10.4 plus a standard deviation, which is 2.4. So that means 12.8 degrees centigrade. We want to know how many days are more than 12.8 degrees centigrade. So looking at our table, if I want a day that's 12.8 degrees, it's going to be here. So I'm going to do the same thing. I'm going to do linear interpolation. So this time, I'm going to draw my number line again. Okay, and put my cumulative frequency up here and my values on the bottom as I did before. So now for that group, the temperature goes from 12 degrees C to 15 degrees C. I'm looking for how many days are above 12.8 degrees C. That's our cumulative frequency. So there are 4, 12, 18, 25 days before. So my cumulative frequency is 25. And by the end of this group, there are 30. And I want to know how many days till I get to 12.8 degrees. So I'm doing exactly the same thing I did before. So I'm going to take my starting point, which is 12. I'm going to add to that my fraction, which is 0.8, out of the whole class, which here is 3, times 5, which is that. This time I'm doing the other way around, so I'm multiplying it by the total number of days, whereas before I was doing it by the range of temperatures. So now I've got 12 plus 0.8 over 3 times 5, and that gives me 26.3 days. And that is question D.